Helium, the chemical element we inhale to produce that characteristic high-pitched voice, is a fascinating noble gas with an equally interesting history of discovery. Although we are familiar with it today and use it in various fields, including balloons, its discovery actually occurred in space before it was found on Earth during a solar eclipse. During the total solar eclipse in 1842, astronomers observed, for the first time, luminous protrusions around the Sun's disk. These bright structures, immersed in the solar corona, had never been seen before. This was one of the first clues suggesting the existence of a new element. However, it would take some time before it was fully understood what had been observed. A crucial step toward the discovery of helium came thanks to French astrophysicist Pierre Jules César Janssen, who, during his observations using spectroscopy, was slowly unveiling the chemical composition of stars. In a letter to his wife written in December 1862, Janssen, who was at an observatory in Italy, expressed his excitement. "I have obtained one of the most beautiful and unexpected results. The spectra of the stars, beautiful, with magnificent colors and lines. Just one more step, and the chemical composition of the universe will be revealed. Spectroscopy, a technique that analyzes the light emitted by an object to determine its chemical composition, would prove to be the key to discovering new elements, including those present in space." The crucial moment came on August 18, 1868, during another total solar eclipse. Armed with his spectroscope, Janssen was observing the Sun during the few minutes of darkness when he managed to spot a spectral line that did not match any known element. That line indicated the presence of a new element, helium. Janssen thus became the first to observe helium in the solar spectrum. But he wasn't alone. At the same time, thousands of kilometers away, British astronomer Norman Lockyer was observing the same phenomenon. He also noticed the same spectral line and, with the help of English chemist Edward Frankland, recognized the importance of the discovery. It was Lockyer who suggested the name, helium, from the Greek, helios, in honor of the sun god. This was because the element had been discovered while studying our star. The discoveries of Janssen and Lockyer reached the Paris Academy of Sciences just minutes apart. Given the timing of the discoveries, the Academy awarded both scientists, recognizing them for the discovery of helium. However, despite the great excitement, there was still a problem. Helium had been observed with a spectroscope but had not yet been isolated in a laboratory. At the time, many scientists were skeptical about the existence of helium. Although it had been observed in the solar spectrum, there was no tangible proof of its presence on Earth. It wasn't until 1895, more than 20 years after Janssen and Lockyer's discovery, that Scottish chemist William Ramsay managed to isolate helium for the first time on Earth. Ramsay was studying a mineral containing uranium when, by treating it with acid, he noticed the formation of gas bubbles. Analyzing the gas with a spectroscope, he discovered that it was indeed helium. It was finally confirmed that helium, present in the Sun, also existed on Earth, though in extremely small quantities. Though heavier than hydrogen, helium is extremely rare on Earth. This is because its low mass allows it to reach high velocities, enough to escape Earth's gravity and disperse into space. This phenomenon makes helium rare in our atmosphere, even though it is the second most abundant element in the universe, after hydrogen. Hydrogen, on the other hand, is abundant on Earth because, despite being lighter than helium, it readily forms more stable, heavier chemical compounds, preventing its escape. Helium, however, is a noble gas, meaning it tends not to combine with other elements, remaining individualistic. But how did helium, a gas so reluctant to combine with other elements, end up inside a uranium mineral? The answer lies in the process of radioactive decay. When uranium decays, it emits alpha particles, which are none other than helium nuclei. This phenomenon confirmed that helium could also be produced by the decay of heavy elements, like uranium, on Earth. Helium is not only rare on Earth, but it is also one of the first elements to have formed in the universe. After the Big Bang, when the universe was rapidly expanding and cooling, the first chemical elements to form were hydrogen and helium. These two elements, the simplest in the periodic table, still make up the majority of the visible matter in the universe today. Hydrogen accounts for about 75%, while helium constitutes about 25%, including that present in the Sun and stars. Today, not all helium is the same. There are different purities and isotopes of helium. The helium used for balloons, for example, has a purity between 80% and 99.99% and is known as balloon grade. However, there are also rare isotopes of helium, such as the highly valuable helium-3. Helium-3 is particularly useful for scientific research, especially in cryogenics, as it is a highly efficient gas for cooling scientific instruments down to just a few thousandths of a degree above absolute zero. This makes it crucial for experiments in astrophysics and particle physics, as well as for the development of future technologies like nuclear fusion. Helium, discovered first in the Sun and later isolated on Earth, is an essential element both in modern science and in our understanding of the universe. From solar spectroscopy to advanced technological applications, this noble gas continues to surprise and play a fundamental role in our exploration of space and matter. Thank you for watching. Leave a like, subscribe to the channel, and activate the notification bell so you won't miss the next videos.